Today, we're digging into a really critical strategic question. How does India actually become a leader in artificial intelligence? And here's the twist. The answer isn't about trying to win the global race to build the biggest, most expensive model. No, it's about playing a smarter game, a more surgical approach that's all about strategic architectural innovation, designed specifically for India's unique future. So here's how we're going to break it down. First, we'll look at the scaling race trap and why it's so dangerous. Then, we'll get into why India's own imperatives demand a totally different strategy. From there, we'll explore that smarter path forward, looking at some really cool architectural innovations and connecting them to real-world Indian challenges. And finally, we'll lay out a clear, actionable roadmap to build a truly sovereign AI capability. If you look around the world, the big story in AI feels like this brute force horsepower race. The goal seems pretty simple. Just build bigger and bigger models, cram in more parameters. But this whole strategy of competing on size alone, well, it comes with some massive and often completely prohibitive hidden costs. And this chart really lays out the stark economic reality. You see, the relationship between a model size and its cost isn't a straight line. It's exponential. As you go from 100 billion parameters to over 1 trillion, the resources you need don't just double or triple, they absolutely skyrocket. For most countries, this path is just not sustainable. It's a recipe for a massive capital drain with smaller and smaller returns, and it creates a dangerous dependency on foreign tech. This quote right here gets to the heart of a major inefficiency. Think about it. So much of our language is made up of static, repetitive stuff. Names, common phrases, facts that don't change. But right now, these huge models use their most powerful, expensive computational layers to basically relearn that static info every single time. It's kind of like using a supercomputer to do basic math. You're just wasting all that incredible power that should be used for actual complex reasoning. Okay, so given those crazy costs and the built-in inefficiencies of the scaling race, let's pivot and bring it all home to India's specific reality. Because for India, chasing a different path isn't just a nice strategic option. It's an absolute necessity, and it's driven by a truly unique set of challenges and opportunities. Let's be real. A generic, super-scaled model that was trained on the global internet just isn't built for India. How is it supposed to handle switching between dozens of official languages and hundreds of dialects, sometimes in the same sentence? Or make sense of all the fragmented data from a massive informal economy? How does it process a legal case file that's thousands of pages long and goes back decades? You see, these aren't just little edge cases. These are core national-scale problems. And to solve them, you need an AI that's built to be efficient, robust, and tailored for these very specific realities. And that brings us to the core of this whole strategy. A fundamental shift in focus. Instead of just pouring billions into brute force scaling, India has this incredible opportunity to lead by pioneering and implementing totally new AI architectures, ones designed from the ground up for efficiency, for memory, and for truly advanced reasoning. So you really have two completely different paths here. On one side, you've got the path of scale. It's all about more parameters, but it's defined by what's called quadratic complexity. Basically, the amount of computation explodes as your input gets longer. This leads to something called context rot, where the model literally forgets what it read at the beginning of a long document. But then you have the path of architecture. It's about smarter design with linear or even constant time complexity. This keeps costs under control and, crucially, gives you robust reasoning over incredibly long inputs. So the first architectural innovation is called conditional memory, or NGRAM. The idea is simple, but it's also pretty profound. It creates a separate, super efficient memory just for static facts. It uses a constant time lookup, think of it like a lightning-fast dictionary, to pull up this info instantly. And this frees up the main model to focus on what it's really good at, complex dynamic thinking. Next up is HEMA, which is a dual memory system that's actually inspired by human biology, which is so cool. As you can see, it separates the compact memory, which is like a running summary of a conversation, from the vector memory, which stores all the nitty-gritty details. This means the model can then query that vector memory to pull up an exact piece of information from way, way back in a long dialogue, solving that huge problem of maintaining long-term context. Now, EMR tackles a totally different memory problem, relevance. Your standard models, they often just retrieve information based on what's most recent or what seems similar. EMR makes the AI's memory way smarter. It uses these learning to ranking techniques, the same kind of tech that powers sophisticated search engines, to score and re-rank all of its memories on the fly. This makes sure that when the model needs to remember something, it pulls up the most contextually relevant piece of information, not just the closest or the newest one. State space models, or SSMs. These are an absolute game changer when it comes to efficiency. They completely break that quadratic bottleneck that plagues standard transformers. By processing information with near-linear complexity, they are fantastic at handling continuous streams of data. So think about real-time sensor feeds coming from thousands of farms in rural India, or processing audio in different local dialects on a cheap, low-power device. This is a critical capability where the traditional, bigger models just fall flat. Recursive language models, or RLMs, are a different kind of brilliant. This is a whole new way of using the models we already have. Instead of trying to cram a massive document directly into the AI, the RLM treats it like an external file. Then, the model actually writes code to break the problem down into smaller chunks. It recursively calls itself to solve each little piece, and then it pulls all the answers together into one final response. It's like giving the AI a notepad and a calculator, letting it solve problems that are orders of magnitude bigger than its own memory. Okay, so we've got this powerful new toolkit of architectures, but how do you pick the right tool for the right job? The next step has to be a clear-eyed, honest comparison to help decision-makers really understand the trade-offs, the maturity, and the strategic fit for each of these approaches. And this table gives you that strategic view at a single glance. Let's zero in on the maturity column. You can see right away that HEMA, RLMs, and SSMs are all near deployable. What that means is that startups and engineering teams can start building really valuable solutions with them today. Now look at sovereignty fit. Architectures like Ngram and HEMA get a high rating because they work perfectly with sovereign data that's kept on-premise. And RLMs are model agnostic, which is huge. It means you can layer them on top of any model you already have, instantly boosting its abilities without expensive retraining. This lets policymakers make smart bets on both short-term wins and long-term research. All right, with that analysis in mind, let's make these ideas really concrete. Because the true power of this architectural strategy, it really comes to life when we start mapping these advanced tools directly to India's biggest, most urgent national-scale challenges. For the judiciary, which is drowning in case files that can be millions of words long, recursive models are the perfect tool to break down and reason over them. For agriculture, analyzing that real-time sensor data from rural areas, efficient state-space models are really the only way to go. And for governance to understand a citizen's long history of interactions with various services, you need ERMR and HEMA to make sure the most relevant context is always front and center. This isn't just generic AI, this is precision-engineered AI for India's specific needs. A great vision is only as good as its implementation plan, right? So we're going to wrap up with a clear, actionable roadmap. This is designed to get the government, academia, and private industry all pointing in the same direction, working toward this common architectural goal. The path forward here is phased and, most importantly, realistic. In the next 12 months, we can get some immediate wins. We can prototype RLMs on top of the models we already have and start benchmarking SSMs on uniquely Indian datasets. Then, in the medium term, say 3 to 5 years, we invest in building our own sovereign foundation models with advanced memory systems like Ngram and ERMR baked in from the very start. And long term, this entire strategy puts India in a position to become a global leader, not by copying everyone else, but by innovating in efficient, architecturally superior AI. And look, success is going to take a coordinated effort. The government has a huge role to play here, shifting funding priorities away from that scaling race and toward this architectural research, while also building up sovereign data trusts. For academia, the focus has to shift to creating new benchmarks that actually test for what matters in India, like long document reasoning, true multilingual fluency, and performance in low-resource settings. And for all the startups out there, the message is crystal clear. The opportunity is right now. You can use deployable architectures like RLMs and SSMs to build incredibly valuable, low-cost solutions today. Let's be really clear about the alternative. The risk of doing nothing, of just continuing down the same path, isn't just big, it's a strategic dead end. Following the global scaling race guarantees a massive drain on capital, a persistent dependence on foreign tech platforms, and ultimately, deploying AI systems that are fundamentally unfit to solve India's most urgent problems. And so, we're left with this final defining question. It's really a choice between two very different futures. Will India keep competing in a race that was defined by others, playing by their rules, in a game of brute force scale it is just not positioned to win? Or will it define its own path, a smarter path, an architectural path, and build a truly sovereign, efficient, and purposeful artificial intelligence? That choice is going to shape the nation's technological destiny for decades to come.